Hey folks, Ms. Gosling here with yet another projectile motion video, and this one is actually our last video. So what I'm going to go ahead and do is read through the problem, and I'm going to talk about what we're going to find and how we're going to find it. Just a heads up, this is going to be the hardest problem of all of the videos that we cover, so you're going to want to pay attention and you may have some questions. If you do, please do not hesitate, as always, to reach out. Now, without further ado, let's go ahead and get into the problem. During the siege of Minas Tirith, the army of Mordor uses a trebuchet to launch a rock into Minas Tirith. The trebuchet has a maximum velocity of 20 meters per second and needs to get the rock over a wall that is 7 meters high and 10 meters away. At what angle should the rock be launched? What angle? And actually, I'm going to do that in a different color because that is my unknown. So let's go ahead and get started. And what I'm going to do first is, as I like to always do, draw a picture. So here is our trebuchet and our rock, and I'm just going to go ahead and draw just the rock. Now our rock has a maximum initial velocity of 20 meters per second, so I'll go ahead and write that in. And we want our rock to travel on a path where it makes it over a wall that is 7 meters high and 10 meters away. And there is all of my given information. Now, this picture is a little bit misleading in that we don't actually know that this is y max. So I'm going to go ahead and just write that in, not y max, as far as we know. And so I can't assume then that v is 0. So I'm going to say v is not necessarily equal to 0. Okay, and now I have all of the information that I need in order to go ahead and start solving. And so to do that, I'm going to go ahead and just start filling out my Suvat tables in the directions. So let's go ahead and start with the x direction. Sx, ux, vx, ax, and tx. So our displacement in the x direction is going to be 10 meters. Our initial velocity is 20 times the cosine of my mystery angle theta, which I'm going to go ahead and draw in here. My final velocity is also going to be 20 times the cosine of theta because, as always in the x direction, my acceleration is 0. And I'm going to go ahead, and for tx, I'm going to go ahead and just write t, because our projectile is going to hit this point here at a time t, a mystery time. Now, I'm going to do the same thing in the y direction. So sy, uy, vy, ay, and ty. Now, my displacement in the y direction is 7 meters, and it's positive because our projectile is still going up. It starts at 0, it ends up at 7. My initial velocity in the y direction is going to be 20 times the sine of my mystery angle. I don't know anything about the final velocity in the y direction, but I know my acceleration is negative 9.8, and the time for the y direction is the same as the time in the x direction because my rock can only exist at one point in time. Or, to clarify, my rock can only exist at one point at any given time. So, let's go ahead and solve this out. So, in the x direction, I am going to use the definition of velocity in order to write an equation using my angle and my displacement and my time. And so I know that u in the x direction is equal to displacement in the x direction divided by time in the x direction. And putting in the numbers from my table, I get 20 times the cosine of theta is equal to 10 over t. And if I solve this equation for t, which you can do on your own, I will find that t is equal to 1 over 2 cosine theta. And I'm going to go ahead and box that. That is going to be my equation number 1. Now, I'm going to go ahead and go to the y direction and get a second equation. So in the y direction, I know that my displacement, s sub y, is equal to my initial velocity in the y direction times my time plus 1/2 times my acceleration times time squared. And I'm going to go ahead again and plug in my numbers. So I get that 7 is equal to 20 sine theta times time plus 1/2 times negative 9.8 times my time squared. I'm going to go ahead and do what I can to simplify, giving me 7 equals 20 sine theta times t minus 4.9 t squared. And this will be my second equation. And now I have 2 equations and 2 unknowns. Even more nicely, in equation number 1, I've already solved for one of my variables, so it makes it very easy to substitute t in our first equation into our second equation. And so I'm going to go ahead and do that. So I'm going to go ahead and substitute. And what I'll do is I will find that 7 is equal to 20 times the sine of theta times 1 over 2 cosine theta minus 4.9 times 1 over 2 cosine theta, that whole quantity squared. And all I'm doing here, guys, is I'm writing my equation for t into every place where I see a t in equation 2. So that way I have one equation and one unknown. Now, it's an ugly equation, for sure, but we can solve this. So let's go ahead and do that. I get that 7 is equal to 10 times sine theta over cosine theta, which, as I hope you remember from your math class, I can go ahead and rewrite as just the tangent of theta. And I'm going to then go ahead and multiplying out all my variables, doing all my squaring, I will find that this next term here is going to be equal to negative 1.225 over cosine squared theta. And again, this is an ugly equation. And with an ugly equation, one of the best ways to solve is to graph it and then find the zeros. So to do that, we first have to set our equation equal to 0 by subtracting 7 from both sides. So I will get that 0 is equal to 10 times the tangent of theta minus 1.225 over cosine squared theta minus 7. And I am going to go ahead and graph this equation. Now again, because this is such an ugly equation, I'm going to go ahead and solve it by graphing. And to do that, I use Desmos, which I believe many of you have used in your math classes. If you have not, you may have used a graphing calculator instead. If you do not know how to use either Desmos or a graphing calculator to solve for the zeros of an equation, I have links in the resources on this page below, and you are also welcome to go ahead and reach out with any questions you might have about how to do that. I'm happy to walk you through it. So what I'm going to do is I'm going to go ahead and I'm going to paste in a picture of the graph from Desmos. So here you go. So you can see in the left is my equation. Note all of the parentheses. I was very careful about parentheses. And note on the right that I have gone ahead and highlighted the intercept of my equation where y is equal to 0. And I find that the intercept here is 42.861 degrees, or about 43 degrees. Now, if you don't get this as your intercept, you're going to want to go ahead into this little wrench tool up here and make sure that you are in degree mode, not radian mode. In your calculator, you're going to want to do the same thing. Make sure you're in degree mode instead of radian mode. And there you have it, guys. That's really all you have to do to figure out your angle. So we took this whole ugly equation and stuck it into a calculator and found that our angle, the angle that we need to launch this projectile at to hit a target 7 meters high and 10 meters away, is 43 degrees. Now you are ready to go ahead and participate in some medieval siege warfare yourself. So best of luck and happy solving.